Good morning, good evening. Hi, thank you so much for clicking on the video. Hi, what's up? Hi, how are you? Hope you're doing well. If you click on this video, that means that you are new to subnetting or you already know a bit about subnetting, but you just want to do a little refresher. First, let me big up the guys who created this website. It's called subnetting.net. You can see it here, subnetting.net. You can go on that website and you get tons of practice questions, really good questions that will sharpen your skills in subnetting. So without further ado, what I want to do is to work out these questions, and while we're doing that, you will be able to pick up some of the concepts that will allow you to be super sufficient and become an expert in subnetting, which is really, really easy. All right, we just need to understand a few principles. One of the biggest one is to convert binary to decimal and decimal to binary. So without further ado, let's just jump into this question here. It says, enter the maximum number of valid subnets and usable hosts per subnets that you can get from the network 172.20.0.0 with a mask of 255.255.255.254. All right, how do you approach this question? The first thing you need to do, the first thing I do, is I convert the binary, the decimal representation of the IP address and mask into binary. And how do you do that? Real simple. There is a little table here that we're going to use to help us in our conversion. And in this table, I'm going to populate it with these numbers: 128, 64, 32, 16, 8, 4, 2, and 1. And you're going to see how that works, right? So remember, the IP address, an IP address is divided into octet. So the 172 here is octet number 1, the 20 octet number 2, the 0 octet number 3, and this 0 octet number 4. Now, inside the computer, it doesn't see, the computer itself doesn't see these as decimal number. It sees them as binary numbers. And in order for us to manipulate these addresses and find out what are the valid hosts and what are the valid subnets, we have to convert them to binary. We also have to convert the mask to binary. So how do we get the binary version of 172? Well, we're going to add these numbers together. Let me show you how. So if I take the 128, so I'm going to put a 1 down here because I'm taking the 128, and I add the next number in line, the 64. I'm going to get 2 carry 1, 9, 1. So I'm actually going to get 192, which is more than the 172 that I require. So I can't use the 64. So I'm going to put a 0 here. What about the 32? If I put the 32 here and add it to the 128, I'm going to get a 0 carry 1, 6, 1. So I get 160. So yes, I can use the 32. What about the 16? If I put the 16 here, so I'm going to add the 16 to the 160. So this is 6, 7, 1. So 176. That is more than the 172, so I can't use the 16. So what am I going to do? You guessed it, I'm going to put a 0 here. What about the 8? If I put the 8, I get a 8, 6, 1. So 168. So yeah, I can take the 8. What about the 4? This is 2 carry 1, 7, and 1. So voila, we are 172. So we take the 4 and we do not need this 2 and we do not need the 1. So the binary representation of 172 is this number here. I'm just going to write it right under here. So it's 101.011.0.0. And I'm going to put back the dot. Awesome. Wasn't that easy? All right. So let us work out what the binary representation of 20 is. So I know I can't use the 128. That's going to take me over 20. Nor the 64, nor the 32. But I can use the 16, right? So I'm going to write the 16 right here. What can I add to it? Can I add the 8? If I add the 8 to 16, that's going to take me over 20. So I don't need the 8. If I add the 4, all right, that's 0 carry 1. So that's 20, right on the money. So I'm going to use the 4. And I'm not going to use the 2, and I don't need the 1. So the binary representation of 20 is 0, let me write the 20 here first. So 0, 0, 0, 1, 0, 1, 0, 0. Put back the dot here. So what is the binary representation of the 0, this 0 here? Well, you might have guessed it. We don't need the 128, we don't need the 64, we don't need the 32, we don't need the 16, we don't need the 8, we don't need the 4, do not need the 2, and we do not need the 1. So the binary representation of 0 is 0, 0, 0, 0, 0, 0, 0, 0. Put back the dot. And then there's another 0 here, so I'm going to put the 0 here, and we already know it is 0, 0, 0, 0, 0, 0, 0, 0. So this is a binary representation of the IP address. Awesome. So now let's work out what the binary representation of the mask is. So what is the mask there? So the first octet of the mask is 255. How do you get 255? All right, let's add 128 plus 64. That gives me 2 carry 1. That's a 9. That's a 1. So I can take these two. I'm not at 255 yet. Let me add 32 to that. This is 4, 2, 2. So I'm going to take the 32. And let me add the 16 to that. This is going to give me 0, carry 1, 4, 2. So I need the 16, and I'm still not at 255 yet. So let me add the 8 to that. This becomes 248. So I'm going to take the 8 and I'm going to move this up because I'm running out of space. So I'm going to put back the 248 and then let me add the 4 to that. This is going to give me 2 carry 1. This is 255. So I'm going to take the 4, still not at 250. This is 252. Still not at 255 yet. So I'm going to add the 2 to that. This gives me 254. So I'm going to take the 2. And then finally, I need to add the 1. That takes me to 255. So the binary representation of 255, of the decimal value 255, is all ones here, right? So now I'm going to put it, look, I'm going to line up these 255. So the first octet of the mask, I'm going to line them up with the bits in the IP address. So, bam, good. And then I have another 255. So we know already that that is all one. So again, I'm trying to line it up with these bits in the address. And you will see why we're trying to line them up. There's another 255. So let's line these up. All right. So now we have 224. How do we get the binary representation of the decimal 224? Again, we're going to add. So let's take the 128 first. And let's add 64 to that. If we add 64, yeah, you guessed it, we get 192, which is more, which is less than the 224. Okay, so we need the 64. Let's add the 32 to that and see what we get. We get a 4, and then this is 2 carry 1, 2. So we're on 224. Boom. So we do not need the 6, we do not need the 8, we do not need the 4, we do not need the 2, we do not need the 1. So the binary representation of 224 is, and I'm going to line it up here, 1, 1, 1, 0, 0, 0, 0, 0. Awesome. So now that we have lined them up, you might be asking, all right, so what's the next step? Okay, so the next step is we're going to do the logical, let me write it here just in case my accent is too thick. logical AND operation between, you see, I tried to line up the bits, so we're going to do the logical AND between this one and this one, this one and this and this and this. Okay, got that? So I'm just going to write the answer right down here. So what is the logical AND of 1 and 1? It's going to be 1. 0 and 1, 0. 1 and 1, 1. 0 and 1, 0. 1 and 1, 1. 1 and 1, 1. 0 and 1, 0. 0 and 1, 0. Put back the dot. 0 and 1, 0. 0 and 1, 0. 0 and 1, 0. 1 and 1, 1. 0 and 1, 0. 1 and 1, 1. 0 and 1, 0. 0 and 1, 0. Dot. 0 and 1, you got it. So all of this, 0 and 1, is going to work out to be 0. And then all of this is 0. So everything down here, even if it's a 1, it's going to be worked out to 0. Got that? So this that we produce here is actually the network. You see that? This is a network. So what is this number here? Well, if you notice, if you're paying attention, this number and this number is the same. So this is actually 172. And if you notice, this number and this number is the same. This is actually 20. And then this is 0, right? So this is 0 and this is 0. So yeah, we are working with this network. The network is 172.20.0.0. You got that? Awesome. I hope you got that. But let's do this. Let us plug this back into our little formula. So let's plug this number, this binary number back into our formula. So it's a 1 0 1 1 1 1 0 1 sorry 0 1 1 0 0. So how do you convert this back into decimal? We're going to add all the bits that have a 1 that are turned on. So the 128 plus 32 and the 8 and the 4. See that? So this is 10, 18, 19, 20, 21, 22. So this is a 2 carry 1. This is 3 and 3, 6. Something is wrong. We're off. So it is 1 0 1 0 1 1 0 0. So this is actually 22. So then I'm carrying a 2. My apologies. So this is 7 and then this is 1. So 172. Alright, so that's how you convert from binary back to decimal. Okay? Alright, so now that we have found out what the address itself is, the network itself, or the subnet, which we know is a 172.20.0.0, we want to find what is the maximum valid subnet and the maximum amount of hosts per subnet. How do we do that? All right, so we have the network here. We know that so we're working with the network portion here, right? We know that the natural mask for a 172.20.0.0 network is a /16, or if it's written in this form, it is a 255.255.0.0. Good, that is a natural mask. So let me just write this natural mask under the network here, and I'm going to write it in its decimal, in its binary notation. We know that the 255 is a 1111111 dot 1111111 dot, and these are all zeros. 4 is 8 zeros, and these are all zeros, 8 zeros. Okay, so this is it. So remember, we're working with this portion now. Good. So this is the natural mask of the 172.20.0.0. Now this is the network that we're working with. This network has been subnetted. Make sense? So this network, the 172.20.0.0, has been subnetted because we have borrowed some of the bit from the natural mask. Do you see that? So this is the mask that we use for subnetting. If you notice, let me remove this just so that we can see it better. Let me see. Let me move this down here. Okay, I need to grab this also. Oh, come on. Okay, and let me just remove this line here. All right, so if we look at the natural mask, we notice that we used 8 plus 8, 16 bits, right? That's the natural mask. But in the subnet, when we have subnetted it, we have borrowed these, which were host bits. So this would have been this is a natural subnet, that these bits represent the subnet, and then these bits would represent the host on the network. But when we did the subnetting, we borrowed some of the host bits. See that? We borrowed some of the host bits to do our subnetting. Yeah? So we have borrowed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We've borrowed 11. Let me just get rid of this. Don't need this anymore. So we have borrowed, and let me get rid of this. We've borrowed 11 bits to do our subnetting. You see that? So the natural mask would have ended right here, but we went ahead and we borrowed 11 bits to do our subnetting. Now, how many subnets would that give us? Well, the easiest way to do that is to say, okay, 2 raised to the 11 is going to give us the amount of subnets. And I can't work that out. I can't bother to work that out. I'm going to use the calculator. So 2 raised to the 11 is, we can get 2,480 subnets. You see that? 2,480 subnets is what we can get if we use 11 bits. And that just means if we change these bits, for example, if I change this to a 0, and then I change this to a 0, and I change this to a 0, or if I change this to a 0. So how many different combinations can we get from 11 bits? The way to work that out is to say 2 raised to the 11. That's going to give me the number of subnets that I can get from rearranging these bits. So turning some to 1 and some to 0. Yeah, that's going to give me 2048. Now, how many hosts can I have per subnet? This is the amount of host bits that I have left. Good. So this is 1, 2, 3, 4, 5. So I have 5 bits that I can use to represent bits, that I can use to represent host. All right, so I'm going to raise 2 to the power of 5, and that's going to give me the number of hosts that are on the network. So 2 raised to the 5. Oh, come on. 2 raised to the power of 5 equals 32. So that 32 is the number of addresses I can use on this subnet. But you have to remember this rule. Even though I have 32 addresses, I have to remember I need one address. I need one address for the subnet, and I also need one address for the broadcast. So that means I need to take away 2 of these addresses, which is going to leave me with 30 addresses that I can assign to host. So I can assign 30 addresses to my PCs, my cell phones, my IP phone, my printer, but 2, even though there's 32 addresses, 2 of them has to be reserved for these functions. Okay, so our number of subnets is 2048, and the number of valid hosts per subnet is 30. There are 32 addresses, but I take away 2, one to represent the subnet itself or the network itself, and then one to represent the broadcast address of that network. Got that? All right, I hope that has been helpful, and you're in a better position when it comes to subnetting. So let us test our answers. The number of subnet is 2448, and the number of hosts per subnet is 30. Submit. Woohoo! We got it right. Okay, let's just recap what we did. So the question asks us what is the maximum number of subnet per valid subnets and the usable host. Remember, usable host per subnet. All right, and then it gave us the address. The first thing we did, we converted the address from its decimal representation to its binary representation, and we use this little table to help us. After we converted the address, we converted the mask. After we converted the mask, we asked ourselves, okay, what is the natural mask for a 172 network? And of course, that is a class B network, so the natural mask is a /16 or a 255.255.0.0, right? We converted that 255.255.0.0 to its binary form, and then we look to see this is the natural mask. That means because these are turned to 1, these were borrowed. So these are naturally the host bits, but we borrowed them and we use them as the subnet bits. So that is what allows us to break up the 172.20.0 network into subnets or mini networks. Okay, so we found out that we borrowed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We borrowed 11 of the bits to do our various subnetting or to create various subnetworks. So we said, okay, if there are 11 bits, what is the quickest way to find out what is the total number of ways you can combine these bits into ones and zeros? And the total number you get is to put 2 raised to the power of the number of bits, which gave us 2,848 subnets. So we can have 2,848 different networks, unique networks, right? And then after we looked at the ones, we looked at what's left, which are the zeros, and we found out that we had 5 zeros left. So these are what we would use to assign to host. So we found out that if we want to find out how many different combinations of ones and zeros you can have here to represent different hosts, you raise 2 to the power of the number of bits, which was 5, and that gave us 32. Now the question asks us for the usable host on the network. So what do they mean by usable host? These are the IPs that we can assign to computers or laptops or printers to host on the network. Now we have to factor in that even though we got 32, we have to take out 1 to represent the subnet itself or the mini network itself, and we have to take 1 to represent the broadcast of that network. We can't assign these to computers or hosts on the network, so they have to be reserved. So that's why we minus the 2 from the 32 and we get 30. All right, I hope that has been helpful. Thank you so much for watching this video. They say if you like it, you should like it. And if you want to subscribe, you can subscribe. All right, so let's move on to another question. And I'm just going to keep the camera rolling, baby. All right, so let me clear up the screen a little bit. And we jump into another question. And if you have any questions, hey, I think I have dyslexia. So sometimes I see a 1 and I say 0. Sometimes I see a 0 and I say 1. Or sometimes, yeah, that's how my brain works. If I said anything that confused you, just put it in the comment below and I will clear it up. Okay? All right. Let's move on to another question. Let's go here. Next question. All right. This one looks juicy. All right. What subnet mask would you use for 172.21.0.0 such that you get 1,180 subnets and 20 hosts per subnet? All right, so they gave you this IP, this network, 172.21, and I'm just spacing it out. You soon say why 0.0. 1, 2, 3. I need another dot somewhere here. I'm gonna put a dot here. All right. So first thing, we're gonna put this in its binary form. All right. So how do you get 172 from our table here? If we take the 128 and we add 64, we're gonna get 192. So we can't use the 64 because that's taking us over the 172. So let us try 32. This is 0, carry 1. This is 6, 1, 160. So we can use the 32. What about the 16? If we use the 16, we're going to get 6, 7. This is 176, which is more than what we need. So we can't use that. Listen, guys, so I'm going to put a 0 here. There are other ways that you can work this out, but I find this to be the simplest way for me. So this is 8, this is 6, carry 1. So I'm going to put a 1 here. And then I'm going to add the 4 to this, and then this becomes 2, carry 1, 7, 1. So I need the 4, and then I don't need 2, and I don't need 1. So this is a binary representation of 172. Let me just write it here. 1, 0, 1, 0, 1, 1, 0. And now, you guessed it, we need to work out what is a binary representation of 20, 21 it is? Yeah, 21. And I know you've gone ahead of me and you've said that this is 0, this is 0, this is 0. Because if I use any of these, I'm going to go over 21. We can use the 16. What if I put the 8 with the 16? So I'm adding 8 to 16. This becomes 4, carry 2, carry 1. Sorry, this becomes 24. So I can't use the 8. Let me just clean this up a little bit. So we cannot use the 8. This becomes 0. What about the 4? Yeah, this gives me 20, so I can use the 4. But if I use the 2, that's going to give me 22. So I can't use the 2. And the 1, if I use the 1, I get 21, right on the money. So I need the 1 there. So this is the binary representation of 21. Let me just write it here. This is 0, 0, 0, 1, 0, 1, 0, 1. And what is the binary representation? Let me put my dots. What is the binary representation of 0? Yeah, you saw it earlier. It's all 0, right? Because we don't need the 128. We don't need the 64, nor 32, nor 16, nor 8, nor 4, nor 2, nor 1. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 zeros, dot. And then this 0, 1, 2, 3, 4, 5, 6, 7, 8 zeros. So this is the binary representation of the address here. Okay, great. Now that we've done that, what is the next step? Well, again, I'm going to say, all right, a 172.21, what is the natural mask for this network? The natural mask for a 172 address is as /16, or written in another way, it is 255.255.0.0. So I need to find the binary representation of 255.255.0.0. And we did it before, but let's do it again. If we're going to get 255, let's take the 128 and add the 64. This gives me 2 carry 1. This gives me 192. Let's add the 32. This gives me 4. This is 2 carry 1, so this is 224. Not at 255 yet, so I have to take the 16. This gives me 0 carry 1. This gives me 4. And this is 2. So I'm going to take the 16. Let me take the 8. This is 248. Still not at 255, running out of real estate, so I'm bringing the 248 up here, and I'm going to add the 4. This becomes 2 carry 1, this becomes 5, so 252. Let me take the 2, because I'm not at 255 as yet, so this is 2, this 4, 5, 2, so 254. And then finally, I need the 1, so this gives me 255. So 255 is written in binary as, yeah, you guessed it, all ones. So it is, I'm going to line them up again. Why does this look so? 1, 2, 3, 4, 5, 6, 7. Wow. I should have 8 bits here. So I need to work out the 172 again. So let's keep, we know that this is, the 255 is all ones. But let's work back out the 172 because I messed it up. I should have 8 bits here. I only have 7 bits. So I'm going to take the 128. So it's a nice refresher, guys. 128. And then I'm going to add the 64. If I add the 64, I'm going to 192. So I can't use the 64. I'm going to use the 32. If I use the 32, I am at 0 here. Carry 1. This is 6, 1. So this is 160. So I can't use the 64. I can use the 32. Let me add 16 to the next one in line is 16, so this is 671. I am over the 72, so I can't use the 16. So I have to zero that bit out. Let me try the 8. This gives me 168, so yeah, I can use the 8. What about the 4? If I use the 4, I get 2 carry 1, 7, 1. So this is the 4, yeah? And I don't need the 2, and I don't need the 1. So I was actually missing a 0 right here. And let me put my dot there. So 0, 1, 0, 0, 1, 1, 0, 0. Good. All right. So we're back on track. So now we're back to putting down the natural mask. And we said that it is, I'm trying to line these up, guys. So this is 1, 1, 1, 1, 1, 1, 1, 1, dot. And then this 255 is 1, 1, 1, 1, 1, 1, 1, 1, dot. And then the 0 is all 8 zeros. So this is 1, 2, 3, 4, 5, 6, 7, 8. And this is all 8 zeros. All right, so we've written the natural mask and we have written the IP address in its binary representation. Now back to the question. We want 1,180 subnets and 20 hosts per subnet. Now remember, the natural mask says that if the address is, if the bits in the address is all 1, sorry, this represents the subnet. And so the subnet, and when it's all 0, moving from left to right, this represents the host. So the natural mask, so I have, the natural mask is telling me that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Natural mask tells me that I have 16 bits that I can use to represent various hosts on the network. So what that means is that I can combine, I can flip these bits, turn one in, turn some into 1, turn some into 0, and do different combination of 1s and 0s to give me the maximum amount of hosts on the network. And the simplest way to calculate that is to say 2 raised to the power of 16, that is the amount of hosts I can get on the network. Let me just grab my calculator here. So 2 raised to the power of 16 gives me, wow, 65,536. Of course, we know we have to minus 2, 1 for each subnet and its broadcast. So the actual valid number of hosts that I can have on this network is 65,534. So this is what the natural mass gives me. See that? And I can do the same thing for the number of subnets, right? If I want to subnet a class B, the 172 network, it would give me the same amount of subnets, right? Because if I count these ones, it equals to 16. So 2 to the 16 gives me the number of different subnets I can have. Got that? Very good. Now that you've gotten that, let us use that information to solve our current issue. Let me just clear up here. Now, the question wants us to get 20 hosts. So, how many bits? So if we come back to the natural address, how many bits would we need to give us 20 hosts? So a while ago we saw that we had 16. We saw that we had 16 bits. And then we said 2 raised to 16 gave us 65,536. So how many bits do we need to get 20, at least 20 hosts? So how many of these bits, how many of these can we take at the end there to give us then the 20 hosts? Right? So let us try. Let us use our calculator. So let's say 2 raised to the 4, that gives me 16. So nah, I can't use 4 bits. What about 2 raised to the 5? That gives me 32. So I'm not going to get 20, but at least I'm not going to get exactly 20. But if I get 32, I'm good, because if I used 4, I would only get 16. So I'm thinking 5, right? So if I take 5 bits, that's going to give me 2 raised to the 5, which equals 32. And I can get my 20 hosts from that. So if I take, starting from right to left, so if I take 1, 2, 3, 4, 5, if I take this 5 bits to represent my host portion, I should be good. I can cover my 20 hosts, right? So the rest of this, I can use that for my subnetting portion, right? Can I? Yeah, why not? So I need 1,180. So let's count. So if I turn all of these 1 into subnets, I need to turn these into subnet bits. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I have 11 bits, and let me just fix this here. This is no longer host because I'm robbing some of the bits. You know what? Let me just clear this out and write them properly so that we aren't confused. So I have, this is 5, so it is 1, 2, 3, and then all of this is going to be 1, 2, 3, 4, 5, 6, 7, 8. So I have 11 bits now. So this is my new host bits because I stole, and let me just break here. Good. Because I stole these 8, 9, 10, 11 bits. So these are now my subnet bits. Subnet bits. I stole 11. So I'm going to draw an arrow here. I stole 11 bits to do my subnetting. So how many subnets will I get? All right, you guessed it. Raise 2 to the power of 11, and that gives me 2 raised to the power of 11 gives me 2,248 subnets. All right. It is more than the 1,180 that I need, but at least it gives me it can cover the 1,180. What if I made it 10? What if I taken 10 bits? Let's see what happened if I took 10 bits. If I said 2 raised to the power of 10, that is 1,024. So I couldn't use 10 bits. I would be less, I wouldn't get enough subnets. So even though it doesn't match properly, I still have to use 11 bits. Okay? So let us test our answer. No, we're not done yet. So we figured out that yeah, we need 5 bits for the host portion, and we need 11 bits for the subnet portion. But no, what is this mask? So we know that this is 255.255, and we know that this is .255 because they're all ones. But what is this? Simplest way, let's plug this back into our formula. 1, 1, 1, 0, 0, 0, 0, 0. So we know that now we need to add 128. Let me write it here. We need to add 128 to 64 to 32. This becomes 4 carry 1. This becomes 3, 9, 10, 11, 12. So 2 carry 1, and this becomes 2. So 224. So the subnet mask that we need for our 172.21.0.0 to give us at least 1,180 subnets and 20 hosts is 255.255.224. Now this is, remember I told you that the address can also be represented by a slash notation. Can you comment and tell me what is the slash notation for a 255.255.224 address? That's a bonus question. All right, so come, let us test to see if we got this correct. So it is 255.255.255.224. Confirming, yes. Let's submit. Let's see if we got it correct. Oh no, we got it incorrect. Ooh, man. Why? What did we do wrong? This looks solid to me. This looks solid to me. What did we do wrong? All right, let me see. Let's go back. We converted our 172. Yeah, this looks solid. We converted our 172.20.0.0 into binary. Then we said, what is the natural mask? We wrote down the natural mask, and we found out that the natural mask ended right here. So we said, all right, we need to borrow some bits. We need to borrow some bits to make some more subnets and some more hosts per subnet. We said that we needed 5 bits. So 5 host bits. So we have to start from right to left. So we needed 5 host bits because we said 2 to the 5. We wanted 30. We needed 20. Let's see. We needed 20 hosts per subnet. 20 hosts. So we said we needed 2 raised to the power. Oops. Clear. 2 raised to the power of 5 would give us 32 subnet. And if we had done 2 raised to the power of 4, we would have gotten 16 subnets. So we need we need to steal, or we need to reserve 5 bits for our host. And then we would have been left with 8 and 3. So these 3 plus these 8 would have left us with 11. So we said 11 bits for the host, for the subnet, sorry. So 2 raised to the power of 11 would have given us 2048 subnets. If we are taking 10 bits, raised to the power of, 2 raised to the power of 10, that would have given us less subnets. So we had to use 11. So we have used 11. Oh, I see the problem. Oh man, I tried 225. It should have been 255. Let me submit that again. All right. Okay. Man, that one had me sweating. Okay, so we got it right. I just wrote the wrong answer in. All right, so again, let me recap this one. Even though we just recapped it a while ago. But anyways, you get the gist. This is how you work these questions. All right, let's move on to another question. Oh man, oh man, oh man. That one had me. I was sweating. That's funny. That was funny. All right, guys. Let's move on. So the moral of that is you need to type the answers in correctly. All right. Makes no sense you work it out and type the answers in incorrectly. All right, let's move on to another question. All right, this one is juicy. So enter, it's short but juicy. Enter the first valid host on the subnet, on the network. The network is 172.29.248.0/21. So we want the first valid host. So again, we need to write our address and mask in binary. You got it. But look at this mask. This is in the slash notation. Good. How do we do this now? All right, so we need to convert. First thing, let us wait. Firstly, I would convert the IP address into binary, but let us wait and do the mask first. We need to put the mask in binary first. Let's do that? Yeah, let's do that first. Why not? All right, so the mask they told us is a slash, get some ink, /21. How do we put this in the x x notation? So by the way, these are octets, right? So this is 8 binary bits, 8 binary bits, 8 binary bits, 8 binary bits, call them octets. But when we write them as numbers, right? So we would write like 255.252.1.0 or something like that. We write them as binary, but the computer in the back end sees them as these 8 bits. You see that? All right, so what is the 24? What does it mean? It means we're going to write back our address in the 4 octets that we saw earlier. So we're going to put 1 octet here, 1 here, 1 here, and 1 here, right? So the 21 means that starting from left to right, I have 1, 2, 3, 4, 5, 6, 7, 8. I have to jump over to the other octet, right? Because I can only have 8 bits in one octet, so I'm on 8 here. So 9, 10, 11, 12, 13, 14, 15, 16. That's another 8. I have to jump over to here. 16, 17, 18, 19, 20, 21. You see that? So I have 21. So how many bits I have here? 1, 2, 3, 4, 5. So I have to put 8, right? So 0, 0, 0. And then for this last octet, it's all zeros. You see that? So 8, 6, 8 and 8, 16, 17, 18, 19, 20, 21. So this is what 21 actually represents in binary. So what is this in decimal? We know that the 11111 is 255 as we saw earlier, and this is 255. So what is this? Plug it back into our formula. So we need 5 ones. So 1, 2, 3, 4, 5, and 3 zeros. 0, 0, 0. And then we just simply add. So 128 plus 64, that gives us 192 plus 32, that gives us 4, carry 1, 2, 2, plus 16, that gives us 0, carry 1, that gives us 240, plus 8 gives us 248. See that? So this is actually 248.0. So a slash 21 mask is 255.248.0. Got that? Very good. So we have the mask and we have it in binary. We also have it in decimal. Remember when we are working these questions, we want our mask to be in binary because we can better manipulate. So let me rub these out. We can better manipulate the mask that way. And we can work our questions easier now that we've converted to binary. And I'm just talking because I'm stalling. I need to move this over here. Oops. Let's undo that. I need to select everything. Oh man, come on. Let me select everything. Very good. So I'm gonna drop the mask right here. All right, let's work out the IP address now. What is the binary representation of the IP address? And the more you work this, the more you'll know you'll know it right off the top of your head. So many times you will not need to convert to binary to find the answers. But hey, we're practicing. So how do we get 172? We get a 128. If we put the 64, we're going to get 192. So we can't put the 64, so we have to have a 0. Let's put the 32. This becomes 0, carry 1. This becomes 6, 160. That's good. Let's take the 16. If we take the 16, that's going to give us 176. So we can't use the 16. So we're going to have to 0 the 16. What if we take the 8? That gives us 168. So we're good. We're less than 72. And what if we take the 4? Oops. I put a 8 here. I should put a 1. Put a 1. No 8 there. We're talking binary. All right. So if I take the 4, this becomes 2, carry 1. Boom. Right on the money. So we take a 4. This becomes 172. So we're at the 172. And then we don't need a 2 and we don't need a 1. And again, we're going to line these up. So the 172 is 1, 0, 1, 0, 1, 1, 0, 0. And I'm making sure I get it correct this time. Great. So now let's find what the binary equivalent of 29 is. And I know that you have started without me and you have said that we don't need this, we don't need this. We can't use this. We can use a 16. What if we add the 8 to the 16? This becomes 4. Carry 1, this becomes 24. So we can take the 8. What if we add the 4? This becomes 28. So we can take the 4. If we add the 2, it becomes 30. So we can't take the 2. And if we add the 1, we are right on the money. We're at 29. So we need the 1. So we're going to write out the binary representation of the 29, and we're going to try to line them up. 0, 0, 0, 1, 1, 1, 0, 1. Awesome. So what is the binary representation of 240? Let me put my full stop, my dot here. Good. So 240, you guessed it, we're going to have to start with the 128. Notice that we're starting from here and we're adding this way. Alright, so 128 plus 64, we know that is 192. So we're going to take the 128 and the 64. What about the 32? If we take the 32, this gives us 4, 2 carry 1, 2. Good. So we can take the 32. What about the 16? If we take the 16, this becomes 0, carry 1. This becomes 4, so 2, 40. Boom, right on the money. So I don't need the 8, I don't need the 4, I don't need the 2, and I don't need the 1. So the binary representation of 240 is, I'm going to try to line it up with the mask here. So it is 1, 1, 1, 1, then 0, 0, 0, 0. And then what is the binary representation of 0? You guessed it, 0, 0, 0, 0, 0, 0, 0, 0. Awesome. So I'm just cleaning up the board here, and then we're going to jump into the meat of the matter. All right, so we want to know what is the first valid host on the network. So we need to find out if this is the network itself. How do we know what if it is the network? We're going to do the logical and between the binary representation of the IP address and the binary representation of the mask. And if you notice, we try to line them up bit by bit. So what is the logical AND? I'm going to say 1 and 1 is 1. 0 and 1, 0. 1 and 1, 1. 0 and 1, 0. 1 and 1, 1. 1 and 1, 1. 0 and 1, 0. 0 and 1, 0. 0 and 1, 0 and 1, 0 and 1, 1 and 1, 1. 1 and 1, 1 and 1, 0 and 1, 1 and 1, dot, 1 and 1, 1 and 1, 1 and 1, 1 and 1, 0 and 1, 0 and 0, 0 and 0. Yeah, you got it. So these are all zeros. So this is our network, or if you want to call it our subnet. If you notice, this and this is the same, and we already know that this is 172. If you're in doubt, you can take this and plug it into the formula here, and wherever you have the ones, you add those numbers together, and I'm betting you're going to get 172. This now, if you notice, this and this is also the same. This was 29, so this is 29 dot. But if you notice, this and this, they are now different. So what is this? Let's put this in our converter table. 1, 1, 1, 1, 0, 0, 0, 0. So we need to add 128 to 64 here. This gives us 192. And then we need to add 32. This gives us 224. Then we need to add 16. This gives us 240. So this is actually, no, that's not right. So this is, yeah, no. You know, it can't be yes and no. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it is 240. But 0 and 1, 0 and 0. Okay. 0 and 1. So 1, 2, 3, 4. This will come. Okay, so 240. All right, come on, man, trust the process. 240, that's 0. So the network itself is 172.29.240.0. So the first valid host is going to be what? All right, so the first valid host is going to be that we're going to change, moving from right to left, we're going to change the first bit to a 1, because remember, this represents the network. So the next valid host, we're going to change this bit to a 1. So it's going to become, you guessed it, but I'm just going to write it here. So remember, this is the mask, right? So this is the mask. So all of this, so from here, all of this is our host bits. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 host bits. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 11 host bits. So this, if we change this bit here from right to left, we're trying to figure out the host, this is going to become 1. So it's going to be all zeros, right? So this is 1. So the first host is 172.29.240.1. That is the first host on this network. Got that? So again, this is the host bit. The first host is going to be the .1. Remember the 0000s, that's the subnet. First host is going to be .1. Second host, .2. But we're going to change the binary bit, right? So it's going to be, this is going to be 1. If we're talking binary, that's going to be a 1 for the first host. And if we're talking binary, this is going to turn to a 1 for the second host. And if we're still talking binary, this is going to be a 1 and a 1 for the third host, and so on and so forth. Okay? All right. Let us try our answer. I hope we got that right. I was a little bit concerned about here, this conversion here, this here. But let's test our answer. Yeah, let's go. So we are saying this is 172.20.240.1. Drum roll. Yes! I was unsure. But yeah, we got that one correct. Again, with these problems, the first thing to do is to convert to binary. Convert the network to the IP address or the network to binary. Convert the mask to binary. Then we're going to do the logical AND to find out what the actual network is. And when we figure out what the actual network is, then we can figure out what the first valid host is. Again, I hope this was clear. When all the bits, remember this is the address that we converted to binary, when all the bits in the address from left to right are 1s, this signifies that these in the IP address, all of these are the subnet, represents a subnet or the network. And then when the zeros that follow represent the host. If you want to get the first host, you're not going to go ahead and change this. You're not going to go ahead and change this to 1. You're going to start from, to work out the host, you're going to start from right to left. And you change this first bit to a 1. Got that? Hope that makes sense. Alright guys, I am going to stop this video because I got to go to work. So I'm going to stop this video. I thank you so much for watching this video. And I hope it has been helpful. Again, if you have any questions at all, you can leave it in the comment below. If you like this video, like it. And if you want to subscribe, go ahead and subscribe. Thank you so much, and I hope you have a blessed and productive day. Peace.